In this video, we're going to do another example of a titration. This time I'm going to change the stoichiometry to 2 to 1. I'm also going to not do one solution titrating another, but one solution titrating a solid. Now the solid is going to be dissolved in water, so the reaction carries out just like you would with titrating two solutions. However, you don't know the volume of the solution. It's not particularly important because we're not going to use V times M to get the number of moles. What we're going to do is use the gram to mole conversion using molar mass. So let's say we have a hydrochloric acid solution we made up, but we don't know what its concentration is. And so what we do is we take a known amount of a base, which we know exactly the identity of that stuff and that there's nothing else in there. So we weigh out 5.32 grams of that, put it in a flask and dissolve it in water. Then we titrate with HCl, and then we find that the equivalence point, which is given by an indicator is a substance which changes color at the neutralization point. And from that, we're going to calculate what the molarity of the acid is that we titrated with. Okay, so the chemical reaction is carbonate plus 2 acidic protons, coming from HCl in this case, gives potassium chloride salt and then carbonic acid, which is H2O and water. But the key thing is we're going to have a 2 to 1 ratio here. Okay, so of these two, which can we calculate first? Well, in order to do this hydrochloric acid solution, we need both molarity and the volume. We only have the volume, so that's clearly not what we can start with. This is where we need to end. What we can do is take the grams of potassium carbonate and convert it to moles of potassium carbonate. All right, so for that we need the molar mass. Okay, 39.1 times 2 plus 12 plus 48, 3 times 16, 138.21. All right, and so it turns out we have .03849. Moles of potassium carbonate. All right. So we could do a conversion factor. Let's go ahead and do that. 1 mole of that corresponds to 2 moles of HCl. And we're going to get 0.07698. And that's going to be equals to V of the acid times the M of the acid. All right, and which of these do we know? We know the volume of the acid, which we determined through the experiment. All right, so we have this number equals that number times M. We divide both sides by 0.02237. And we get 3.441 molar. Probably 3 significant figures for everything, so 3.44 molar. Maybe a bit stronger than you'd normally like to work with,